Welcome to this video, and today we're going to talk about the R values in linear functions. So the South Carolina standard that we'll be addressing today is to compute using technology and interpret the correlation coefficient of a linear fit. So what does that mean for students? Students will be able to demonstrate an understanding of the linear strength of a scatter plot by interpreting the R value, and students will be able to find the R value using technology. Okay, so the correlation coefficient, R, measures the strength and direction of a linear relationship between two variables on a scatter plot. Okay, so the line of best fit is this line right here, which is the line that can best represent this scatter plot, all these little random points that we have. This is the line that we can use to best represent that data. And so the correlation coefficient, R, measures the strength and the direction of a linear relationship. So strength and direction. We can go and look at this. So the direction, if it's going in a negative direction, we will see it going downhill. The line of best fit will be going downhill. And that makes sense with slope, since a negative slope is going downward. And the same happens for R. So that's what we mean by the direction. So from this we can see that this will have a negative R value since it's going downward. Okay, but the strength. Okay, so if it's a 0, then there is no strength, there is no linear relationship. But you can see as we go up farther away from 0, then we start to get progressively stronger and stronger. But R values are only between -1 and 1. So a perfect 1, that's like writing an equation, 2x plus 1. Exactly -1, that's like -2x plus 1. It's perfect. So we have weak. The closer it is to 0, the weaker it is, and then as it approaches 1, it'll get stronger. So if we look back at this, we know that our R value will be negative. And it's not the strongest, but it's also not the worst. So judging from this, I would say between -0.5 and -0.7 would be that R value. Okay, now let's use this in the real world. So here we have Figure 1, which is race and ethnicity of those killed by police under all conditions. And this is from 2015 to mid-2018 compared to the general population. So we're going to take this set of data, and I'm going to use Desmos to put that data in so we can create a scatter plot. So here we have the data from the chart earlier of the race and ethnicities killed by police, and the green here is whites, and then blacks, Hispanics, and then these orange dots are others. Okay, so this line right here, this line of best fit, what would we think this R value would be? It's going downward, so we know it would be negative, and it looks pretty close to these points. So this looks like a strong R value. Now let's look and see. And yes, right here we can see R value negative 0.9333. So that is negative, and that's a very strong R value. Okay, well how can we do this in Desmos? We'll go down to this set of data right here. This is for other people who identified as other for the data that we're using. Okay, so we want to make this look like a linear equation. So we'll do y4, this column right here, and then this little squiggly. And then what does the equation of a linear line look like? mx plus b, right? So we can do mx, but this is x4. We have to account for that column. and then plus B. And looky there. We have this. We could change this color just to make it a little bit more easier to follow along. Okay, so this R value, let's see what it is. Oh, so this is a positive one. This is a positive R. So R is, the trend line is going up. And it's pretty strong. It's a 0.9. So all of these, this page, this link to Desmos is going to be below the video, and you can kind of look at these and discover more of what's going on and what's happening with line of best fit. I hope that this helped.